Welcome, listeners, to another My Mind MashUps deep dive. Great to be here, where we unravel mysteries, spark curiosity, and, try to make sense of these huge, complex ideas together.
And today's is a big one.
It really is. We're diving into, the ultimate question of selfhood. What are you actually made of? Is it just, flesh and bone?
The standard electrochemical signals in the brain.
Exactly. Or is there something deeper, something almost hidden? Are you fundamentally a pattern of information woven right into the fabric of the universe?
And that's our mission for this deep dive. We're looking at two really radical answers to what philosophers call the hard problem of consciousness.
The hard problem?
Yeah, basically, why does having a brain feel like anything? The experience of seeing red or feeling happy. The qualia.
So what's the divide we're looking at?
The central question is this: is yourself, your consciousness, defined by its material components? The actual quantum particles?
What hardware?
Or is it defined by the organization of its processes, the software, the pattern of information itself?
And the stakes here they're massive. If it's about the physics, we might be these unique biological miracles.
But if it's just about information structure,
then consciousness could exist anywhere. In silicon, maybe even in much simpler things.
Exactly. It completely changes how we see ourselves and our place in the universe.
It really does. And if you enjoy content that makes you think, well, don't forget to like, share, and subscribe.
Please do.
Okay, let's jump in with the first idea. This one is probably the most controversial theory out there. It's called orchestrated objective reduction.
Or QOR, short.
Right, OR. It was proposed by Nobel laureate Sir Roger Penrose and Stuart Hameroff.
And they looked somewhere no one else was really looking. Not at the big neural networks, but deep inside the neurons themselves.
To these little protein filaments.
Microtubules. They're like the cell's internal scaffolding. And the idea is that these microtubules can act as basically quantum processors.
So how does a conscious moment happen, according to them? It's not the usual neuron firing story, is it?
Not at all. They argue a moment of consciousness happens when a pre-conscious quantum superposition.
So the microtubule is in multiple states at once.
Exactly. And that superposition self-collapses into one single definite conscious event. Penrose calls this objective reduction and says it's tied to non-computable physics.
Okay, non-computable. That's a huge word. What does that actually mean for us, for our minds?
It means that human thought, our intuition, our creativity, it involves processes that a standard computer, a classical algorithm, simply can't replicate. No matter how powerful it gets, it puts a hard limit on what classical AI can ever achieve.
It sounds revolutionary, but it immediately ran into a huge scientific wall, right?
Oh.
The decoherence challenge.
Oh, absolutely. This was the killer objection for a long time, and physicist Max Tegmark put it most bluntly. He basically said the brain is just too warm, wet, and noisy.
Right. It's not a sterile lab environment.
Far from it. And these delicate quantum states like superposition, they should just, poof, fall apart. Decohere in something like 10 to the minus 13 seconds.
Way too fast for any kind of thought to form.
Exactly. If his math is right, the theory is, as you said, dead on arrival.
But, and this is a big but, the field of quantum biology has kind of thrown a wrench in that whole argument.
It really has. That idea that life is too messy for quantum effects. We're finding that's just not true. We now know that things like photosynthesis.
In a leaf.
In a warm, wet leaf, yes. Or how birds navigate using Earth's magnetic field. These are living systems that protect and use quantum effects at room temperature. So if a plant can do it,
why couldn't a brain?
The possibility is on the table.
And there's more direct evidence, right? The connection between anesthetics and these microtubules.
This, for me, is the most compelling clue. We know anesthetics turn off consciousness, and we also know they bind specifically inside these microtubules.
That feels too specific to be a coincidence.
I think so. And there are experiments to back it up. If you give rats a drug that stabilizes their microtubules, makes them stronger, they become way more resistant to being knocked out by anesthetic gas. It strongly suggests that whatever consciousness is, microtubule function is absolutely critical to it.
And people are pushing this even further. I saw a mention of a 2022 claim. Highly speculative, I should add.
Very speculative.
That they might have detected entangled brain states using a special kind of MRI, a quantum connection across the whole brain.
Right, the Kurskins paper. Now, that is hotly debated. A lot of critics think the signal could be an artifact to something else entirely.
Sure.
But the very fact that people are now designing experiments to look for this stuff in a living, conscious person, That shows how much the thinking has shifted. The idea of a quantum self isn't just fringe philosophy anymore.
Okay, so that's a powerful case for the hardware, for the physics being essential. But let's completely flip that. Let's transition to the informational self. The idea that maybe we're just the software.
Right, this is the pattern view, championed by people like Max Tegmark, actually. The idea is that your identity, your consciousness, is just a data structure, a very complex program.
He said consciousness is the way information feels when being processed in certain complex ways.
And that's the key. This makes consciousness substrate independent.
Meaning the material doesn't matter.
Doesn't matter at all. Carbon, silicon, smoke signals, in theory. If you replicate the pattern and the processing perfectly, you replicate the consciousness.
So you could, upload your mind, swap out your neurons one by one from microchips, and as long as the program stays the same, you're still there.
That's the idea. And to give this some mathematical rigor, we have integrated information theory, or IIT.
Developed by Tononi and Co.
Yes. And they try to quantify consciousness with a specific value. They call it phi.
So break that down for us. What exactly is phi?
Phi, or I, is a measure of a system's integrated information. It's how much information is generated by the system as a whole, above and beyond its individual parts.
Okay, and an example.
Think of a car engine. It's complex, but if you take out the piston, it still exists as a piston. The parts don't require each other to exist. It doesn't have hi-fi. But a conscious brain is totally different. Every part is so deeply interconnected and causal, you can't separate it. The whole is fundamentally more than the sum of its parts. That intrinsic, unified causal power. That's phi.
And if phi is the true measure of consciousness, that leads to some pretty wild philosophical places.
It really does.
Right.
Because if phi is all that matters, then any system with any non-zero phi must have some tiny glimmer of experience.
Even something like a thermostat? Or a light sensor?
According to the theory, yes. A tiny, vanishingly faint glimmer of consciousness. This is a form of panpsychism.
But a constrained panpsychism. It's not that everything is conscious.
No, not at all. It's that any system with integrated information is conscious.
Yeah.
So consciousness isn't some magical property of life. It's a fundamental property of information structure.
So we have these two completely different ideas. Orchawar says the feeling of being you comes from a specific quantum collapse in your brain cells.
Right.
And IIT says that feeling is just what hi-fi information integration feels like from the inside, no matter what it's made of.
Two very different paths to the same mystery.
It's a lot to take in, and if this is resonating, hit that subscribe button so you don't miss the next deep dive.
You won't want to miss it.
So if we are these patterns of information, what happens when that pattern looks out at reality? This brings us back to quantum mechanics, doesn't it?
It does, but from a different angle. It forces us to ask what our role as observers really is.
And this is where the physicist John Archibald Wheeler comes in.
Yes, with his famous phrase, it from bit.
It from bit.
His idea was that every physical thing, the it, fundamentally emerges from information, from bits, which are resolved by an act of observation. He called it a participatory universe.
A participatory universe. So the universe needs us, the observers, to become fully real.
That's the radical implication. The properties of a particle, for example, aren't fixed until someone or something measures them. And this bizarre link is captured perfectly in a thought experiment called the Wigner's friend paradox.
Let's walk through this one because it really gets to the heart of the problem.
Okay, so imagine your friend, we'll call them the friend, is inside a perfectly sealed lab. They perform a quantum measurement, like checking a particle's spin.
And inside the lab, the friend sees a definite result. Spin up or spin down. For them, reality has chosen.
Exactly. For the friend, subjectively, it's done. But you, Wigner, are standing outside the lab. From your perspective, you haven't seen the result yet.
So for me, the entire lab, including my conscious friend,
is still in a quantum superposition. The friend is in a state of seeing spin up and seeing spin down at the same time until you open the door.
So who collapsed the wave function? My friend or me? That's the paradox.
That is the paradox. It shows that when you put a conscious, subjective self into the equations, standard quantum mechanics seems to break. It suggests the observer has this irreducible role in defining what's real.
Which brings us right back down to Earth and to AI, because if consciousness is just about complex information processing,
then a big enough AI, like a large language model, should eventually become conscious.
If the pattern view is correct, yes. Given enough complexity, sentience should just emerge.
But our other theories, ORCAR and IIT, They throw up huge roadblocks to that idea. They say classical AI is missing something fundamental.
And they're missing different things according to each theory.
Completely different things. For Orksar and Penrose, the missing piece is that non-computable quantum process.
That quantum heartbeat.
Right. They would argue that a classical AI can only ever simulate understanding. It can't have a genuine moment of insight or creativity because it's limited by its algorithm. It needs that quantum gravity-driven collapse.
Okay, but IIT has a totally different complaint. AI is all about information, so what's its problem?
Its problem is the kind of information processing. IIT claims most current AI lacks that intrinsic causal power, that hi-fi.
Why?
Because their architecture. They're often feed-forward. Information goes in one end, gets processed through layers, and comes out the other.
There's no loop.
There's no loop. Exactly. There's no deep re-entrant causal structure where the whole system is constantly influencing itself in a unified way. An AI might perfectly mimic being conscious, but IIT says it's an empty shell because it doesn't have that integrated causal core. It's a pipeline, not a nexus.
So this is the ultimate dilemma. Does real consciousness need that specific, weird quantum biology?
Or is it just an emergent property of any sufficiently complex classical pattern?
And the answer basically determines whether we can ever truly build a sentient machine or if we're just biological one-offs.
It's the test, really. If an AI one day passes every conceivable test for consciousness using only classical computing, it would be a huge problem for a theory like Orksar.
But if they keep hitting a wall, a barrier of true subjectivity,
then the quantum and biological theories get a major boost.
Wow. So we've looked at the self as quantum particles and microtubules, and the self as a pattern of information defined by phi. We're standing at this crossroads of physics, philosophy, and neuroscience.
We really are.
Maybe the best way to think about it is that we're both. Maybe the particles are the notes, the information is the melody.
And consciousness is the song.
Exactly.
And if we really take the Wigner's-Friend paradox seriously, it leaves you with a final, really provocative thought to sit with. If yourself, your mind, is fundamentally tied to the act of measurement,
to resolving that quantum uncertainty,
then the simple act of you being conscious, of you observing the world, might be elevating the mind from just a passenger in the cosmos to an active, essential participant in its very existence. Your mind isn't just in the universe.
It's helping to define it.
It could be.
Like, comment, and subscribe to hear more My Mind Mashups deep dives.
We'd love to have you back.
You can find My Mind Mashups everywhere you listen. That's Amazon Music, Audible, Facebook, Pocket Casts, Spotify, TikTok, and YouTube.
We're all over.
And please, drop your thoughts in the comments. Are you the particles or the pattern? Your perspective could shape our next deep dive.